Okay, in this lesson we're going to use those properties of exponents that we learned in 8.1a and use them to help simplify our radicals and rational exponent expressions. So recall that our exponent rule, when we're multiplying and the bases are the same, you add the exponents. So x squared times x to the fifth would be x to the seventh, using that product of power rules. So if you had 5 squared times 5 to the third, you'd get 5 to the fifth. And we could simplify that one since it's a base of 5. So 5 to the fifth power, I don't have a calculator on me, but let's see, 5 times 5, 125, 625, 3,125. So now if you have 5 to the 1/2 times 5 to the 2/3, you would add the exponents, 1/2 plus 2/3. Now since they are fractional exponents, in order to add them, we do need a common denominator. So between 2 and 3, they have 6 in common. So I can change 1/2 to 6 by multiplying both the numerator and denominator by 3. So 1/2 is the same thing as 3/6, and 2/3 multiplied by 2 is the same thing as 4/6, and so this would be the same thing as 7/6. So that's 5 to the 7/6. Or you could say that's the 6th root of 5 to the 7th power. And then if you write it in the root form, we can simplify it even further, because now we have 5 sevens down here, and we have a 6th root, so you could take out one group of 5. So you have 5, and then there'd be the 6th root of 5 left in there. So this would be the most simplified version of this. Writing that back as a fraction would be 5 times 5 to the 1/6 power. So typically we'd see it written like with the radical in that case. So anytime you have an improper fraction, you should recognize that it can be simplified further. Okay, more of the same. So this might help if we go from the radical form here and change it to exponent form. Since I see that I have 2 5s, the bases here are the same, which means I should be able to work with the exponents. So we have to remember that if you have a power of n over, oops, I think I wrote that backwards actually. I think we have m in the top and n in the bottom. Then it's the nth root of x to the m power. Or sometimes it's the nth root of x and then the power goes on the outside. All of these are equivalent. So we can rewrite the 4th root of 5 cubed as 5 to the 3/4 power times, then this is 5 to the 1st, so 5 to the 1/3 power. Now we can add up those exponents. I'm going to do that over here. 3/4 plus 1/3. We have to get a common denominator. That would be a common denominator of 12. So 9/12 plus 4/12 would be 13/12. So this would be 5 and 13/12. So bases are the same. So we are adding the exponents, which means that would be the 12th root of 5 to the 13th power. Since we have 13 5s out there, we can take one out front. So it'd be 5 12th roots, and there'd be 1 5 left over. This would be the simplified version of that expression. So another thing to notice then is what happened here. If the bases, what we did is we multiplied these roots together. 4 times 3, we got 12 here. And then we kept that, so that worked out here because that was the denominators, made 12. If the roots are the same, like this one, cubed root and cubed root, that's if the exponents are the same, then we can combine the cubed root we can combine what's inside together. So 25 times 5. And the reason we were able to do that is because they are the same root. And then before I multiply this together, I'm going to break down 25 as 5 times 5. And we got one more 5 here. So 5 times 5 times 5. And then notice that it's a cubed root and I have a group of 3. So the cubed root of this is 5. So it just equals 5. Because 25 times 5 is 625. Or 125, I mean. And the cubed root of 125 is 5. Okay, x squared times x to the cubed root of 3. Bases are the same, so you are adding those exponents. Now we have a rational number and an irrational number, so it's going to be 2 plus the cubed root of 3. And that does not simplify any further, so that's the answer for the third example there. So in number 1, we had bases that are the same. The 5s were the same. In number 2, we had the roots were the same, so we could combine the roots. And in number 3, the bases were the same, so we added the exponents. Okay, remember the quotient rule. When you're dividing and the bases are the same, the quotient rule says that you subtract the exponents. So 5 minus 3 is 2, you'd have x squared. So applying that rule, 2 to the 5th, 2 to the 3rd, you'd have 2 to the 2nd. And 2 to the 2nd is 4. It works with rational exponents too. Notice how the bases are the same, 2 and 2. So you subtract the exponents. So 2/3 minus 1/3 is 1/3. Now 2/3 is greater than 1/3, so it's going to end on top. So you're going to have 2 to the 1/3 power. This is a simplified fraction. It's not improper, so that's as far as it's going to simplify. You could rewrite that as the cubed root of not the cubed root of 3, but the cubed root of 2. That's the same thing, going back and forth between rational and radical exponents. Remember the product or power to a power rule. When you have an exponent raised to a power, you multiply the exponents. So x squared to the 3rd is x to the 6th. So 5 squared to the 3rd would be 5 to the 6th. We could evaluate that. I don't have a calculator on me right now, so I'm just going to leave it as 5 to the 6th for the point of this example. It works with rational exponents too. If you have a power raised to a power, even if it's a fraction, you multiply those exponents. So it'd be 2/3 times 3. When you're multiplying fractions, you multiply across the top, numerator times numerator and denominator times denominator. So I made 3 a fraction by putting it over 1. So 2 times 3 is 6, and 3 times 1 is 1, 3, and 6 over 3 reduces to 2, so it'd be 5 squared, and 5 squared is 25. That one I don't need a calculator for. Power to a power here. So we multiply the exponents, and the square root of 5 times the square root of 5 is just 5, because 5 times 5 is the square root of 25. Since the roots are the same, combine what's on the inside, and that's just 5, square root of 25. So you'd get x to the 5th for that one. Remember the rule of negative exponents. If it's a negative exponent, it must end positive. So you'll need to move it and use the reciprocal and make it a positive exponent. 5 to the negative 2 then would be 1 over 5 squared, which simplifies to 1 over 25. 25 to the negative 1/2 would be 1 over 25 to the 1/2. Now 1/2, remember, is the same thing as the square root of 25. And the square root of 25 is 5. So that would simplify to 1/5. We wouldn't want to leave the square root in the denominator. So some more simplifying might be necessary in some cases when you have to rationalize the denominator. In this case, it did simplify. So, all right. So let's look at this example. We got multiple things going on here. Let's first simplify our constants. 18 divided by 6. is 3. 6 goes into 18 3 times, 6 goes into 6 once. So 3 over 1. The 1's not necessary, but you could write it. Then the r's. We got r to the 1/4 over r to the 1st over r to the 1/4. So we're dividing, so you're going to subtract the exponents. So you need to do 1 minus 1/4. Remember that 1 is the same thing as 4/4. 4/4 make a whole. So 4/4 minus 1/4 is going to be 3/4. And since 1 is bigger than a 4th, the r's will end on top. It'll be r to the 3/4 on top. Then we have an s. S doesn't go with anything, so s to the 2/3 will stay on top there. And t down here, we have t to the -3. That one we're going to have to bring to the numerator to make it positive. So bring that up and make it t to the 3rd. And it's all over 1. So our final answer will be r to the 3/4, s to the 2/3, and t to the 3rd. Since these are not improper fractions, it's okay. This is simplest form. It's okay to leave it like that. Remember quotient of powers rule, when you have something raised to an exponent, that's a division problem, you have to distribute that exponent. So you're going to get 2 to the 3rd, x to the 3rd. 2 to the 3rd is 8, and then x cubed. So remember that exponent goes to both. It works the same way with a fraction. So it'd be 8 to the 1/3 and 27 to the 1/3. Or you could think of that as the cubed root of 8 over 27, which means it's the cubed root of 8 over the cubed root of 27. Now 8 is 2 times 2 times 2, and 27 is 3 times 3 times 3. And so the cubed root of 8 is 2, the cubed root of 27 is 3, so this simplifies to 2/3. Just block that off here. 27x to the 3rd raised to the -1/3 power. So we can't have this negative root here, so we'll make that positive by moving it to the denominator, taking the reciprocal. Now we can simplify this by either distributing this exponent, so you got 27 to the 1/3, and that'd be x to the 1st, because you do multiply the exponents, power to a power. Or you can change it back to a root. A 3rd power is the same thing as cubed root of 27x cubed. The cubed root of 27, that's 3 times 3 times 3, and x is x times x times x. So we can take out a 3, and we can take out an x, and there's nothing left over. So it'd be 1/3, 1 over 3x. Couple things to remember. If you have rational exponents in simplest form, you can't have any perfect squares or cubes or anything under a radical. Like, for example, remember the square root of 90. That's the same thing as the square root of 9 times 10. Well, 9's a perfect square, so you can't leave it under there. You have to say that's 3 square roots of 10. You have to simplify it. You can't have negative exponents. If it's in simplest form, they do need to be made positive. And no rational exponents in the numerator and denominator. So no fractions, no rational exponents in numerator and denominator. I think that's more for the denominator. No radicals in the denominator. Maybe we want you to leave it back in rational form. Double check what I wanted you to come up with there. Okay, here's a few examples then. So if you have a square root, remember that you square root of a fraction, you can split that up and take the square root of the top over the square root of the bottom. And square root of 4 is 2, the square root of 9 is 3. So it simplifies to 2/3. If you can go backwards. If you have a square root divided by another square root and you know that 27 is divisible by 3, you can put it back together and say 27 over 3, so you get the square root of 9, which is 3. So this would be easier than rationalizing the denominator. So if you recognize that the roots are the same and these two numbers are divisible by each other, put it back together, simplify it, simplify it. It'll be easier than taking it by the square root of 3 on top and bottom and dealing with all that big numbers and simplifying it. You get the same answer. If you have the roots are the same, you can multiply what's on the inside. So 5 times 2, and you get the square root of 10. Here's another example where the roots are the same. So we got the square root of 3 and the square root of 3. And I know that 34 is divisible by 4. 32 is divisible by 4. It's actually 8. So 32 over 4 is the cubed root of 8. And the cubed root of 8 is 2. So the roots are the same and you know you can divide these, put it back together and simplify. And then simplify more if you can. So here, in this first example, 10 over 15 could be simplified. These could all, 10 and 15 are both divisible by 5, but 21 and 15 are both divisible by 3. So I'm trying to decide which one would be easier to divide first. Maybe get rid of the 21. So I'm going to put those together and say square root of 21 over 15. Well, that's going to be divided by 3, 7, divided by 3, 5. So you're going to get the square root of 7 over the square root of 5. So now that's the square root of 70 over the square root of 5, or the square root of 70 over 5. 5 goes into 7 one time, 14 times. So this is square root of 14. And now 14 is just 7 and 2, so that can't be simplified any further. So the square root of 14. Now you could have just did 210 on the top and then over the square root of 15 and then divided that out. But I don't have a calculator on me, so I was trying to simplify it without a calculator, which might be tough here. 196, let's see. 196 is the square root of 14, I believe. 14 squared. So 196 is 14 times 14. And we have 2 cubed roots. So we can make this all one big cubed root. And then we have 3 14s, so it's 14 times 14 times 14. Now, there's no use multiplying that out since I have a group of 3 14s, which is what I need. So whatever this large number is, the cubed root of it is just 14. So using my rules, knowing that the roots are the same, I can combine that, which means I need a group of 3. No roots in the denominator means you really need to rationalize it, so you can't have the square root of 3 down here. How I get rid of it is multiplying it by the square root of 3. Whatever you do to the top or bottom, you have to do to the top as well. 7's on the outside of a root, so 7 goes on the outside. So it'd be 7 square roots of 3 in the numerator. Square root of 3 times square root of 3 is 3. Because square root of 3 times square root of 3 is the square root of 9, and that simplifies to 3. Now 7 and 3 are both on the outside, but that doesn't simplify any further. Over here, since it's the square root of 2, I have to multiply by the square root of 2 on top and bottom. So it'd be 5 square roots of 2, and then square root of 2 over 2 is 2. Now the 5 and 2 are what's on the outside, but that doesn't simplify any further. This 2 is on the inside, this one's on the outside, so you can't simplify those. Same idea with all roots. You can't have a cubed root in the denominator either, except for that for a cubed root, I need 3 2's. I have 1 2, I need 3 2's to get out. So I actually need 2 more 2's on the denominator because then I would have the cubed root of 8, and the cubed root of 8 is 2. So this would give me the cubed root of 8. I'd get left with 2. So that means I need to take the top by the cubed root of 4 as well, because 2 times 2 is 4. So it'd be 7 cubed roots of 4. So when it's not a square root, and a square root you need a group of 2, and a cubed root you need a group of 3. In a fourth root, you need a group of 4. So I have 1 3, I need 3 additional 3s. So now I have a group of 3s that I can say, well, that will just equal 3 then. And whatever I do to the bottom, I have to do to the top. Now 3 times 3 is 9, 9 times 3 is 27. So really I'm taking it by the fourth root of 27. So it'll be 5 fourth roots of 27 over 3. Here, remember that any root you can split up if 7/8 doesn't simplify, so you take the fourth root of the top over the fourth root of the bottom. Now, 8 is a large number, so I'm not looking for 4 more or 3 more 8s. That would really be just too big. You have to think about the 8 itself is 4 times 2, and 4 is 2 times 2. So I have 3 2s. So really, I just need 1 more 2 to get a perfect fourth root. So I can just take it times the fourth root of 2 on both the top and bottom. So now on the top, I have a fourth root times a fourth root. So your answer is a fourth root, and 7 times 2 is 14. On the bottom, you have 4 2s, so you can take out the group of 2, and so the fourth root of 16 is just 2 on the bottom. You can apply the same properties with variables. This is a review from Algebra 1, but we'll do a couple here. If you have 27, you break it down with your factor tree. 9 times 3, 3 times 3, and then z to the 9th really is 9 z's. It's a cubed root, so you need groups of 3 to form a perfect cube. So these 3 3's, the cubed root of 27 is 3, so that comes out. And we have 1, 2, 3 z's, and z times z times z will be z cubed. Now I took everything out of the radical, so the radical is no longer necessary. Same over here of x to the 4th and the 4th power, so it's just equal to x. I get one group of x. This is really x to the 4th, which is x to the 1st power. Anytime I have a 1/2 power, I like to change that back to a square root. So square root of 16, g to the 4th, h squared. Square root of 16 is 4. G to the 4th, well, that's 4 g's and 2 h's. So this is a square root. So the index on a square root, remember, is 2. So you need groups of 2. So I have 1, 2 g's, so g squared, and 1 h. Now everything came out of the square root, so no longer needed. That would be the answer. The 5th root, you can split up and do the 5th root of x to the 5th over the 5th root of y to the 10th. Well, this would be just x, the 5th root of 5x's. Now here you have 10y, so you can take out 2 groups, so it'd be x over y squared. You could change this back to fractional exponents too. It'd be x over 5 to the 5th, y over 10 to the 5th, which simplifies to x over y squared too. So fraction or radical. So there's your review. Simplify as much as possible. Don't leave anything in fractions, especially if it's a improper fraction, then it can be simplified. So good rule of thumb, change it back to radical and simplify it from there. All right, hope this was helpful. Thanks.